Section 8.5. Indirect measurement. How do we measure things that would be difficult to measure in another way? So for this first example, we are up in the mountains and we're at a lake. So here's our lake. And our friend is at the lake. What's that?
Who's not?
We are.
Oh, we are.
We are. And there's a little picnic area. They like to do picnic areas right at the side of the lake. And over on this side of the lake, there's a tree. And we're there with our friend, and our friend, as we're eating our picnic, says, I wonder how far it is across that lake. And you, being a really smart geometry student, you tell your friend, I can figure it out. And they really don't believe you. But you don't have a boat, you can't go measuring, you can't drag a tape measure across the lake. But you say, trust me, I can figure this out. So what we do is we get in our car and we drive. And as we drive, luckily the road that goes away from the lake happens to be at a 90-degree angle to this distance that we're looking for across the lake. As we drive, we notice another tree here. There's a tree that we drive past. And we look at our odometer when we pass this tree, and we see that we've driven 5.4 kilometers. We have a European car, so it measures the distance in kilometers. And then there's another road down here that is at a 90-degree angle to the first road. The distance from the tree to the other road, turns out we look at our odometer, and it's 3 kilometers. And we're almost done. We're feeling really clever because we know we've almost got this figured out. So we drive along this road until we can look directly across here and line up the tree. Let me draw my line. Let me redraw my line. Line up the tree with the tree that we drove past on the road with where we are on our road. So it turns out that we've driven 10 kilometers along this road. And we tell our friend, okay, we've got it now. We know how we can figure out how far it is across that lake. This is easy. But your friend still thinks you're crazy, doesn't understand how you're going to do it. Well, we have two 90-degree angles here. What do we know about this angle and this angle? They're congruent, right? What kind of angles do we call those? They're vertical angles. So we know that those two angles are congruent. Well, we have an angle in this triangle, and an angle in that triangle, angle in this triangle, angle in that triangle. So what do we know about these two triangles? The triangles are similar by angle, angle. And we're trying to find x here. We're trying to find the distance across the lake. So because we have similar triangles, what can we do, guys? What can we do with the sides? We know that the sides of similar triangles are proportional. So we can set up proportion. We can make ratios of the sides, and they have to be the same. So we're looking for x. So I'm going to use this big triangle here. X divided by 5.4. And what's going to be my other ratio? 10 divided by 3. X matches up with this side, the long side, and 3 matches up with the 5.4. And we're set. Cross multiply now, and I get 3x equals 10 times 5.4. This is easy. 3x equals 54. Divided by 3, and x equals 18 kilometers. So just by driving around a little bit, we were able to figure out that it's 18 kilometers across the lake. And your friend decides that it was a good thing that he didn't decide to swim across the lake because that's too far to swim. Any questions on that example? All right, well now we have a reputation. You have a reputation as someone who can figure out how far it is across lakes. So now you're on another picnic at another lake in the mountains. You like lakes in the mountains. They're nice places to have picnics. And there's a picnic area on the side of this lake, just like the other one. They like to build picnic areas. And there's a tree on the side of this lake that we can see. Whoops. The tree has long roots. And your friend says, your other friend says, I hear you can figure out how far it is across lakes. Can you figure out how far it is across this one? You've got a reputation. And you say, sure, I can do that. But you want to impress your friend, so you're going to do it a different way than you did it before. So this time we start by driving directly away from the tree. So we're going to drive directly this direction. So we drive quite a ways this time. We're enjoying the scenery, so we drive a ways. So we drive 25 kilometers. And after we drive 25 kilometers, we turn, there's a road at 90-degree angle, and we drive down this way. And this is a 90-degree angle, and we drive 90 kilometers. And we sight directly across here to the tree. Well, now we have a big triangle. Your friend still doesn't believe that you can figure this out because all you've done is drive around a little bit. Well, now you're going to drive back to the picnic area. And your friend's convinced that you have no idea what you're doing. Well, it turns out at the picnic area, there is another road that goes directly this way. And this is a 90-degree angle also. They laid out the roads next to this lake really very symmetrically. And so now you drive along this road until you reach this line of sight here, and you've driven 75 kilometers. And now you tell your friend, I've got it, I can figure it out now. And your friend still doesn't believe you. So we look at these triangles. We have a big triangle here, and we have a small triangle here. Don't they share this angle? Yes? So they share that angle. So I have an angle here, and a 90-degree angle here, an angle there, and a 90-degree angle there. So we know, what about the triangles? Triangles are similar. So their sides are proportional. So we can set up our ratios with our sides. So I'm going to start with the small triangle. I'm going to say x, which is what we're trying to figure out, over 75 equals, so we have this side of the small triangle and this side of the small triangle. What are we going to match up with x? Would it be, is 25 so we have the side of the small triangle and the base? 25 plus x, right? The whole side of that triangle is 25 plus x. So the side of the big triangle is 25 plus x. The base of the big triangle is 90. So we make our ratio 25 plus x over 90. And I write parentheses around here because not only are we good at geometry, we're good at algebra. So our friend is starting to maybe see what we're doing here. We cross multiply 90x equals 75 times 25 plus x. We distribute here. 90x equals 75 times 25 is 1875 plus 75x. We subtract 75x and we get 15x equals 1875. Divide by 15 and x finally equals 125 kilometers. So it's 125 kilometers across that lake. And your friend is really glad that didn't go for a swim. Just like last time. And now you've cemented your reputation as the lake measuring person. Any questions on those? So it's just a couple of ways that we can use similar triangles to measure distances by doing exactly what we've been doing with our problems, setting up ratios of the sides and setting them equal to each other because we know that the triangles are similar. All right, one last thing we need to talk about today. So two new similarity theorems. And these are things that we can figure out if we already know that the triangles are similar. So I'm going to kind of combine them both into one. If two triangles are similar, their corresponding altitudes and medians have the same ratio as the sides. So this just gives us another thing in a triangle, another part of the triangle that we can set up a ratio with when we know that our triangles are similar. So let's draw a picture so we remember what altitudes and medians are. Our altitude is, we said the altitude when we talked about triangles, altitude and height are kind of the same thing. We use the word kind of the same. The altitude goes at a 90-degree angle from one side to the opposite vertex. So this is an altitude. And the median goes from the middle of the side to the opposite vertex. So the median cuts the opposite side in half. So this is a median. Altitude, 90-degree angles to the opposite vertex. Median, middle of the side to the opposite vertex. And if we know the triangles are similar, these two, then the altitudes of the two triangles are going to make the same ratio as the sides of the corresponding of the similar triangles. So any questions on what altitudes and medians are? just going to do a couple of examples and then we'll be done. All right, so for these examples, we know that the triangles are similar. We want to find x. So for the first one, we have our triangles look like this. And we're going to draw in the altitudes. And this is a 90-degree angle. And we have 9 and 6. And this is 6 and 4. And this is 5.25. And this is x. So we want to find x. Well, we know that the triangles are similar, so the altitudes have the same ratio as the sides. So how are we going to set up the ratios here to make our proportions? What do you want to do?
Would it be 9 over 6 equals 5.25 over x?
5.25 over x. Perfect. 9 divided by 6, the ratio of the sides is 5.25 divided by x. I could do 6 divided by 4 is 5.25 over x. I could do 9 over 5.25 equals 6 over x. So I can make those ratios, as long as I'm comparing the same part on each triangle, making the ratio from the same parts on each triangle, your answer will come out the same. So now we cross multiply, we get 9x equals 6 times 5.25. So 9x equals 6 times 9.25 is 31.5. Divide by 9, and x comes out to be 3.5. So it just gives us another part to make proportions with. Questions on that example? So again, more of the same. Set up proportions, cross multiply to solve. All right, let's look at an example with medians, and then we'll be set. Again, our triangles are similar. So here are our triangles. And we know that these are congruent and those are congruent. And we have 5 and 4 and 7 and x. Not drawn to scale. So we know the triangles are similar. We have the medians here. The medians make the same ratio as the sides. So how do we want to set up our ratio? 5 over 7 equals 4 over x. Comparing this side to this side, this median to that median. Cross multiply, I get 5x equals 28. Divide by 5, and x, when I divide that out, I get 5.6. Again, just another way to set up ratios with our sides. Questions on that? Okay. Let me